Hello students, Mr. Sims presents recorded video lessons. This would be day 4 in our equation/geometry little module. We're going to be talking about angle problems and solving equations. So yesterday in Fast and Furious, or previously in Fast and Furious, we just worked on angle problems where we found the missing angles. Okay, today's lesson objective, I can use equations to find the missing angle. So in here we have the facts, angle facts and definitions. These are a review of what you put in your tip journal, but because vocabulary is so important in geometry, it's pretty good to reference this. So adjacent angles are just two angles that are next to. And really what I want you to get out of maybe this vocabulary so much is how angles are named. So here's the diagram, and you got angle A and you got angle B, and they're using little letters. Little letters are typically used for inside of the angle, whereas the capital letters are used for around the outside. So to name an angle, A degrees, right, is really the same thing as angle. Now the way that angles are named is we use 3 letters. So we start here. So if I were to outline this, I follow the letters B, A, C. This would be angle B, A, C. This is my symbol for angle. And it's the symbol that's used in geometry later on in math. All right, so really it's about just naming these angles. Okay, 3 letters. Follow the map. A, B to A to C. All right, so then angle B, or B degrees, would be the angle from C to A to D. Angle C, A, D. And that's how angles are named for the most part. Sometimes you'll see them as numbers as well. The one thing that's important is that middle point. All right, vertical angles. Yesterday we talked about vertical angles. Vertical angles are the same, okay? But they have to be formed by 2 intersecting lines. So this is a line, and this is a line. So the vertical angles would be the angles that are across from each other. So we would say angle DCF and angle GCE. GCE. Right? Angles along a line, also known as, you'll see this word from time to time, linear. Okay? They equal 180. 2 or more angles in this case. So like for example, if this angle was 130 degrees, then this angle would have to be 180 minus 130 or 50 degrees. All right? So that's something about that. Is when you find straight lines, every straight line equals 180 degrees. And then angles along at a point equal 360 degrees. So all of these angles together would equal 360 degrees. All right. So because in this class I'm not really concerned as much. Later on you'll be concerned about actually naming some of these diagrams. Let me hit the focus button here. Oh, that's not the right button. Focus button. All right. So in a diagram, here's a specific diagram. There are a lot of things that are kind of in here. So this here represents that entire angle. It would be these 3 angles added together. All right. And if you add these 3 angles together, all 3 of these angles together should equal 180 degrees because that forms a straight line. Okay, the other thing you'll see in diagrams from time to time is this box. And that box represents the fact that these 2 angles together would equal 90 degrees. All right. So if you took 53 and added 37, you get 0, carry 1, you get 90 degrees. All right. Other things, right? When you see a bunch of these, if I cover this up, okay, I got a line. Every line's 180 degrees. So if I add the 79, the 48, and the 53, all 3 of those would equal 180 degrees, right? Also, I could cross it off up here. So then this 90 and the 37 and 53 would equal 180 degrees. So a lot of it's going to come down to how you visualize and what you see in these diagrams. All right, and then here you got your vertical angles, 53 and 53. Note, this angle here being 48 degrees and this angle here being 90. They may look like vertical angles, but they're not vertical angles because you would have to extend this line. Okay, it has to be opposite of 2 intersecting lines. All right. All right, real quick, this was kind of a quick one, then we'll get into the examples that I'm going to model for you. So Find the measure of x. So you have a straight line to 180 degrees, so really we work backwards. So 132 we take away from 180 degrees, just like we did on the warm-up. It's actually easiest to be 8. This becomes a 7, minus 3 is 48, so this will be 48 degrees. All right, so let's turn to the next page, and I've got a couple of examples that I'm going to model for you. And in these examples, I'm going to model using algebra. So this video might last a little bit longer than some of them usually do, but so here's example number 1. All right, so you're being asked to find the measures of angle BAC. So remember we talked about getting the gist. What are we looking for? That angle, and we're looking for that angle, DAE. So in this particular case, we have algebraic terms that are involved here. We've got a 3x, we've got a 2x, and something's missing. But if you notice, there is a box. So what we do is we put 90 degrees down. All right, so what we've got in this diagram is we've got a straight line. Every straight line equals 180 degrees. So I'm going to write an equation. So this is a connection to how you can use equations to help solve. The one thing that's really nice about geometry is there's no negatives. So we don't really have to worry about making negative mistakes. And if you get a negative number, then you know you've done something wrong. So I'm going to add these angles together, the 3x plus the 90 plus the 2x. So over here, I'm going to write it out, 3x plus 90 plus 2x. And there's your equation. Okay, like I said, no negatives. So variables on the same side, so we combine them. 5x plus 90 equals 180. And then from here, should be smooth sailing. Shouldn't be surprised by what I'm doing here. Solving this equation, we get 5x equals 90. I'm going to come over here because I'm out of room. 5x equals 90. That over so you can see. Divide by 5. Save a little bit of math, you get 18. Okay, but here's what's different about this sometimes. Is when you solve for x, sometimes you're done. But in this particular case, this just represents what x is. When I go back in the diagram, angle BAC is 3x's. So I'd have to take 3 times 18. And this one over here is 2x's. So this would be 2 times 18. All right, so we can go ahead and multiply it out. 2 times 18 is 36 degrees. So DAE is 36 degrees, and CAB is 54 degrees. And you can check this by taking 54 plus 90 plus 36. All right, example 2, we just did one just like that on our warm-up. So I'm going to leave that alone for now, and we'll go right to example number 3. All right, and I'm actually going to show you 2 different ways that you could approach this, depending on how you see this problem. All right, so write an equation for the angle relationship shown in the figure and solve for x. So there's actually a couple different things that some of you may use. All right, so first of all, the angle relationship that's involved in this problem is you see you're given 85 degrees here, and you're given these 2 angles here. You're given the 3x and the 16. Right? You're not given these angles at the moment. All right, so if you're not given those right away, talk about trying to conserve steps. The relationship that appears here is vertical angles. This 85 should equal, now we got this little extra piece put in here. It's actually it's called an array technically, but so it means that this 85 really has to equal the 3x plus the 16. So I can write an equation based on that. So this is 85 degrees, and this is 3x plus 16. All right, and that's using the vertical angle. So then from here, you subtract 16, you get 3x equals 69, divided by 3, and you get x equals 23. And they wanted you just to solve for x. So in this particular case, you would be done. Right? But now some of you may not see that vertical angles relationship. So when that happens, I remember these types of problems when I was growing up, and I would say, find all the angles. And if you find them all, you're going to figure out what you're looking for. Right? So some of you may think to use the 360 degree rule. But if you use 360 degrees, you need these angles. And they're not given to you. But here's the thing. We can find this. We have a straight line here. Every straight line is 180 degrees. So I can take 180 minus 85. And that means that that angle is 95 degrees. And this angle are vertical. So this is also 95 degrees. So what I can do is I can add up all the angles that I know. The 85 plus the 16 plus the 95 plus the 95. And I'll just try to do this quickly. I know we're running in almost 10 minutes here. 15, 1 carry 2, 10. 29, 291. So then I can take the 3x plus all the angles that I do know. 3x plus 291 equals 360. And solve this equation. Or work your way backwards. So when you subtract 291 from both sides, you get 3x equals 69. So you still get the same thing. Right? Okay, at this point, what you will do is there are some exercises on pages 10 and 11. You'll work through those exercises, although make one change for me very quickly. On page 11, exercise number 2, just don't worry about this so much. Just make it an X. I got a little bit confusing in yesterday's class. All right, so work on these exercises. It is your checkpoint. You check in with me, and then we move on to independent practice. So for recorded lessons, this is Mr. Sims signing off.